So this will be the last lesson of the course, the one lesson for week 4, where I'm going to work through the part of the lessons for production in RAG and other aspects that we have seen. The first of all is what we have learned that are issues when we deal with RAG. The first one is the conversation that a user has with a RAG agent is not a conversation optimized for making queries to a RAG system, to complete an embedding and make a query to an embeddings database. Because, for instance, if I ask what was the champion of Wimbledon last year, and then the RAG system is going to go through the words Wimbledon and last year, and there we will have a problem here because the RAG system will not know what the last year, but maybe you would get it because it will get like the champion from the last 10 years, and the model in the system prompt will get the year, the date, and it will be able to answer. But here, we may find a first moment. If I say last year, we don't know. But it gets worse, because if in the second message I said, and who did he play the final against, now the RAG query is completely clueless, doesn't know about Wimbledon, doesn't know about the year, doesn't know about nothing, and the LLM will have to provide you with an answer that you get from a RAG system with no valid context at all. That's why in the LAMP project we identified this, because users told us. They told me, hey, I'm asking a question, then I ask a follow-up question, and the model doesn't know anything. Why? Because the second retrieval is absolutely clueless about what is the topic, because the topic is not encoded in the query that we are sending to the embeddings database. The solution we came up is called context-aware RAG. As you know, we have several kinds of LLM models, and state-of-the-art LLM model is a big model, is expensive, and it's mostly slow. But we can, on our provider, we can choose a fast model. For instance, OpenAI has the nano models. The nano models is a model that is the same family that the state-of-the-art model, the SOTA model, but it's smaller. It's a smaller distillation and will answer fast, and it will be very cheap. So what we did is, with context-aware RAG, is to say, before we send the query of the user to the embeddings database to get the retrieval, what we do is let's process the whole context, the queries, all the context that we have, all the conversation, and we process it, and we ask a fast model to provide us with an optimal query for the RAG system. And there you have it. And this does work very well, because if I ask who was the champion of Wimbledon last year, if I put in the system prompt the date and the time, then the fast model is going to know, I know the date, I know what date is, I know what last year was, so I can build a query and say, tell me the champion of Wimbledon men's singles for 2025. And now I'm getting a context. And when I do a follow-up question, who did he play with? Then the fast model can say, okay, we just ask who was playing, who won the last year's championship of Wimbledon. And now he's asking who is playing with. He knows that we are making a reference to the previous question, so it will build a query organized to get the details of the final of last year's Wimbledon, and we will get a correct question. So the idea is, instead of sending directly what the user asks, process a little bit the query with an LLM and proper information, what date, and even what is, we can feed into the fast model some information about what is this agent, this assistant about? What are we trying to get? You can put a lot of information in the fast query so we can get a really good query for the embeddings database, and we can test it. The other part that we have to know is, in addition to build a context-aware database, you can create a list of conversations that you have against your agent, and you can run it a lot of times, and then you can use an LLM to evaluate the correctness. You can say, this is the conversation, this is my expected result, and with these optimizations I'm getting this result, and the LLM will say, yes, it's a quite close result, or no, it's a crappy result, so you should improve and put better context, put better information, or make a better query, or improve the prompt of the fast model that you're using. So context-aware RAG is something that you have to experiment, because simple RAG is what we said. It's just simple and it's not ready for production. You need to work at it, and the good news is that we can use a model before we ask the embeddings database. That's the first thing. The second thing is that tokens. We are expending tokens, and the cost in time and money of using LLMs is the cost in code tokens. What the hyperscalers did in 2024-25, started doing in early 2025, I think, maybe before, is to create a KV catch, a K-value catch system. You know, the LLM has two phases, one where everything has to be calculated in parallel. This is computing intensive, and this part is really expensive. It's going to be calculated for all the context. But the good news is that if we always are sending the same context over and over again, all the calculations of K-value for this context have already been calculated, so we can use the old and loved method in computer science of using a catch, which is like a sort of memory of what we did before, so we can reuse it and not do an expensive retrieval, for instance, to disk, or in this case, a recalculation of all the keys and values for the context. So what the LLM providers do, they create this KV catch system. What they do is they break down into fragments all the context that an LLM is receiving, and they hash each one of them. So when you do another query, another completion request again after, let's say, 5 minutes later, they will look in the KV catch, in the KV catch, if your context hashes are present in the memory, and then if this context is present, it will use the KV catch, so you will save a lot of time. And if in paid APIs, we are saving as much as 90% of the cost. So think, if we have one big context, let's say 500,000 tokens, and we are saving 90% of the cost, this can start becoming a lot of money that we save. Now let's think back to our simplest RAG system, the simple file RAG. We were placing, in a naive way, the context inside the prompt template. We usually did that because early tests provided better results, putting it in the prompt template, because it's the last thing that you tell the model, so it's really relevant. But the idea is that if we design our assistant in a way that we, instead of putting the single file in the prompt template, we put it in the system prompt, it will be the file of text, the RAG that we're doing with a single file RAG, we're doing it in the beginning of our context, and is always going to hit the KV catch. So we will only pay for the big file that we're putting in the single file RAG the first time. The next time it will be catched. And this is even better if we have many users of the same assistant, because two users making a query against the same assistant are going to hit the same KB catch. So you have 10 users, you will always use the same KB catch, so you will save a lot of tokens. After the prompt system and the first message, each will be different, and then you will not have the ability to catch. But since the KB catch is going to make a hit, so an assignment, and it says out of the course, no exercises to deliver now, study how a KB catch work in the documentation, in the PDFs. I will provide you with documentation about how works the KB catch, but think always when you build your context, when you build your assistant, you have to use the idea of the KB catch and this KB catch, and then when you design your context, think what is going to get inside the KB catch. And this is valid for the design of assistants, for RAG assistants, and for agents as well. So all the skill, for instance, if you design an assistant and you start using skills, put the skills up so they're reused. And the content, and we can take advantage as much as possible of the KB catch. Our scaffolding should be aware of the existence of KB catch, and we have to use it wisely. Then we see here an opportunity, because if I'm doing a RAG assistant and I'm putting the single file RAG in the system prompt, it's really easy for me to design a RAG system where the single file is in the system prompt, and I can put a RAG, a complex RAG, an embeddings RAG in the prompt template, so I can combine single file RAG and embeddings RAG. And this can be done in really interesting ways, because you can have like an outline, a summary of what the assistant is about and all the information that the assistant needs to know, and then use the embeddings RAG, the embeddings database, to complement the conversation on each turn with relevant, really specific information. And you can start making interesting designs. And if you combine this with testing of the behavior of the assistant, then you can fine-tune really well how it's going to work, this assistant. And then remember, an assistant is something that is meant to replace ChatGPT. And so we are looking for something fast that is going to answer fast. Then, if you want to explore more the world of RAG and RAG assistants, for instance, there's a whole literature and projects in GitHub that use graph databases. So instead of having a database with embeddings, which is probabilistic, then you will have a deterministic graph, and you will get maybe sometimes better information with less time. It's something that you have to explore. Then the idea is, if you really want a capable assistant, then you don't need an assistant, you need an agent. When you have an agent that can execute tools, that can query a database, that can interact with CLI tools, so it's a different beast. It's something that you are disposed to wait for. I will wait for an agent to do a hard task, to look for information. For instance, yesterday I had one certificate that I received 2 years ago on my email, and it was impossible to find it on my Gmail, and I told Bilby, my Gmail and G Calendar and to-do list agent, please find this for me. I don't care how much time you take. And in like 20 minutes, I found the document. Great. I don't care waiting for 20 minutes. If I have an agent, I will wait for the answer of the agent, because I want a high quality and something that an assistant is not able to do. And here we come with an idea that Andrej Karpathy proposed, which is a wiki. We will link in the documentation the article of Karpathy and his wiki, but the idea is that instead of building a RAG, an embeddings database, you build on your hard drive a structure of files and folders linked with markdown wiki links. So all the documentation, all the information in all the documentations that you use, and all the papers that you write, and all the papers that you read, and everything that you have is combined. And then you can use LLMs, and you can use the agent to go through all your material and cross-reference, put in wiki links between all your information. Then your agent, when it has a query, they can go through all the documentation, follow the wiki links until they find the right information. And then you get the perfect RAG. The problem is that it's going to be slower. And the problem is that it's going to be optimized for instance, a user. But for me, it's the future. On the front of agents, if you want to learn more about agents scaffolding as we are right now in 2026 summer, there's an open source agent project. Is a minimalistic agent project called Pi. And this Pi agent is written in Node.js and is production ready, and you can install it instead of Cloud Code, for instance, and it's a really good minimal scaffolding of an agent. But there's a broader project, there's a sibling project of Pi called Thou. We will link it, and Thou, it's an educational project that makes an smaller implementation of Pi, but it makes the implementation in Python, and it's designed as an educational tool. So when you are ready, you're through reading all my code, then you can go through to Thou and read the code of this agent. And you can even fork the Thou agent and use it as the source for your customized agents. Last but not least, if you want to learn more, everything that I know about how to build agents right now is written in a paper that I have published with some friends in Archive. It's called Agents All Way Down, and proposes a methodology, a software engineering methodology of how you can build and orchestrate agents. If we had to cover it in this course, we will need like 3 weeks more, so I'm not going to do that, but I'm sure that with the knowledge that I have provided you, make available to you in this course, you will be able to read the paper, understand it, and take advantage of it. So that's it for the course. I hope you enjoy it. You know where to find me, and make more questions. Now get out there and learn.